All right, ladies and gentlemen, in our final video for chapter 10.2, we are going to discuss similar circles. And I'm going to keep it pretty basic, folks. The reality is that all circles are similar. All circles are similar to one another. How is this possible? Well, it's all about proportions. That's what it comes down to. It is all about proportions. They are all similar. The reason being is that they're really the only dimension specifically for a circle that we're looking at is the length of the radius in itself. And so if I bring my my compass back on out, if you take a look here at this circle that I'm going to randomly draw, right? If I make this circle here, and let's say, for instance, that I cut the distance of this radius in half. So you may call that a scale factor of 1/2, right? So I'm going to really kind of just ballpark what I think maybe half of that radius is going to be, right? Ultimately, every single radii that I could draw from this center point would have been affected by the same scale factor of quote unquote 1/2. And that is true if I expanded it on out. And let's say, for instance, maybe I just did a scale factor of 1/4. And so I made it 3/4 of the original big circle. And maybe it looks something like this, right? And so then now every single radii that originally I had for my big circle was impacted by a scale factor of 1/4. So all of those dimensions end up having the exact same scale factor on them. It's not like a triangle where you have to take into account three separate side lengths or anything like that. So that's why it's simple to say that all circles, of course, are going to be similar in nature. So I have a question on up here that I want you guys just to kind of think about. If you're with someone, maybe you can have a quick conversation as well too. But it says your friend claims that any two arcs with the same measure are similar. Any two arcs with the same measure are similar. Your cousin claims that any two arcs with the same measure are congruent. Who is correct? So I challenge you, pause the video, think about it for a sec, and see what you come up with. So ultimately, what do you think? Your friend claims that any two arcs with the same measure are similar, but your cousin claims that any two arcs with the same measure are congruent. The reality is your friend is correct, because if they have the same arc measure, they could be similar circles, right? But just because they have the same measure doesn't mean they have the same arc length, which means they would be of non-congruent circles. So in order to be a congruent circle, remember they have to have the same radius. And so your friend would be correct in this aspect. Now I'm going to do one example with you guys just to kind of close up things here. And then on your notes, you will see a tiny URL that I want you guys to fill on out. Now this is going to be kind of a randomized example, if you will. It says find the measure of the red arc after finding the value of x. I'm going to do this number 23 here with you guys. And then if you go ahead and on your notes, finish up number 24 and input it into the tiny that you see there. So what do we know? Well, we know that the measure of arc AB is a semicircle. That means it's 180 degrees. That means that the reality is that XAC plus arc BC, which is 2x minus 30, have to add on up to our semicircle at 180 degrees. If I can erase my one that I'm trying to draw here. So minus 30 equals 180 degrees. You get 3x equals 210. Therefore, x has a measure of 70. And so that means that this guy here, of course, is 70 degrees. And if you plug it on into the value of 2x minus 30 for arc BC, you get 2 times 70, which is 140, and then subtract 30 is 110. Of course, you could have just subtracted 70 from 180 degrees, and you would have had the exact same result as well.